The star Betelgeuse, a red, very massive monster found in the superb body of Orion, has long charmed stargazers and cosmologists alike because of its sheer size and brightness. In the event that Betelgeuse were placed where our Sun is, it would extend out to the orbit of Jupiter, affirming its colossal size. Despite being located around 642 light-years from Earth, its gigantic size makes it quite possibly one of the most brilliant stars visible to the naked eye. Recently, Betelgeuse has shown bizarre behavior such as amazing darkening and lighting up cycles, which many researchers believe signal that the star is approaching the end of its life. The famous physicist Brian Cox recently made a critical statement that Betelgeuse is on the edge of a devastating blast expected to occur within the next 2 weeks. This event, known as a supernova, will mark the end of Betelgeuse's life, but will provide a phenomenal opportunity for researchers to study one of the most surprising and powerful phenomena in the universe. As a red supergiant, Betelgeuse is classified as one of the largest and most massive types of stars. It has been on the astronomical radar for many years, but its new eccentric fluctuations in brightness have sparked theories that it is preparing for a supernova. When a star like Betelgeuse reaches the end of its life, its core implodes under its own gravity, leading to a massive explosion that releases an enormous amount of energy, radiation, and cosmic material into space. Betelgeuse's approaching blast is anticipated to be a Type II supernova, a specific type of celestial explosion that happens when the core of a massive star collapses. This core collapse triggers the release of neutrinos and radiation, creating a shock wave that tears the star apart. The explosion will be so bright that it may be visible from Earth without telescopes, possibly even outshining the moon in the night sky for weeks or months. While such an event would normally be catastrophic if it happened near Earth, Betelgeuse's distance of around 642 light-years means that although the blast will be visible and dramatic, it will not pose any danger to life on our planet. Nevertheless, the event promises to reshape our understanding of supernovae and cosmic phenomena. A supernova is one of the most powerful events in the universe, releasing more energy in a few seconds than the Sun will release throughout its entire lifetime. Betelgeuse's blast will not just be an astonishing cosmic display, but also a significant moment for science. Researchers are eager to observe this intriguing event from its earliest moments using a variety of ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to capture as much data as possible. When Betelgeuse explodes, it will emit a wide range of radiation from visible light to gamma rays. One of the most crucial aspects of the supernova will be the flood of neutrinos, those elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually reach Earth before the light from the blast due to their ability to pass through almost everything without being affected. Observatories like Japan's Super Kamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, providing an early advantage in monitoring Betelgeuse's final moments. The explosion will also provide vital insights into the creation of heavy elements. When stars detonate, they produce and scatter elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will offer researchers a clearer view of this element formation process, which is crucial for understanding the formation of planets and the chemistry of the universe. While Betelgeuse's supernova is not expected to have a destructive impact on Earth, it will interact with our planet's atmosphere and magnetic field in captivating ways. The energy burst from the explosion, specifically the emission of cosmic rays and charged particles, could result in more intense auroras, expanding the regions where the northern and southern lights are visible. While these cosmic rays could affect satellite communications and some technologies on Earth, the disruptions are expected to be minor and brief. Perhaps one of the most exciting parts of Betelgeuse's blast is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For weeks or even months, Betelgeuse is expected to be the brightest object in the night sky, potentially even visible during the daytime. This spectacle will captivate not only the scientific community but also amateur astronomers and the general public, sparking renewed interest in space science and the universe. Scientists have long speculated about Betelgeuse's death, but Brian Cox's recent statement adds a sense of urgency. Observatories worldwide are preparing to monitor every phase of the supernova, and the data collected will be critical, potentially changing our understanding of stellar evolution, supernovae, and the distribution of heavy matter in the universe. Betelgeuse's supernova will allow researchers to refine their models of cosmic distances. Being relatively close to Earth, it offers a unique opportunity to measure how energy from such a blast travels through space. By observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust between stars, astronomers will gain a clearer understanding of the size of the universe. The event will also offer a once-in-a-lifetime opportunity to investigate dark matter and how it might influence the structure of the universe. Dark matter, the mysterious substance that makes up about 85% of the universe's mass, does not emit or absorb light, making it difficult to detect. However, observing how light and matter behave around Betelgeuse after its explosion could provide indirect clues about the role dark matter plays in the universe's large-scale structure. Betelgeuse's supernova will also bring us closer to understanding the life cycles of stars, particularly how massive stars contribute to the formation of the elements essential for life. Supernovae are the key cosmic events responsible for spreading heavy elements throughout the universe, elements that ultimately form new stars, planets, and even living things. By studying Betelgeuse, scientists will gain valuable insights into how these elements are created and distributed. The social significance of Betelgeuse's explosion is also important. For centuries, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most visible stars in the Orion constellation will provoke philosophical reflection on the transient nature of the universe. In some cultures, such divine events have been interpreted as omens or signs of monumental change. Betelgeuse's blast may inspire a mix of awe, fear, and wonder as people from all walks of life witness the death of a star. This grand event is likely to reignite interest in space exploration and stargazing, drawing more people into the search for knowledge about the universe. Amateur astronomers are already preparing for the event, as modern technology allows nearly anyone with a camera or telescope to observe and record the supernova. This democratization of science will unite people across the globe, all watching and recording the same massive phenomenon from their unique vantage points. Betelgeuse's explosion isn't just a spectacular cosmic event, but also a stepping stone for future exploration. The data gathered from the supernova will inform how we study other stars, particularly as we venture further into space with missions to other planets and stars. Understanding the life cycles of stars and the properties of supernovae is crucial as humanity looks to extend its presence in the solar system and beyond. Additionally, the explosion will reignite interest in the search for extraterrestrial life. Supernovae are essential for spreading the components needed for life, like carbon and oxygen, across the universe. By studying Betelgeuse's explosion, scientists can better understand how the building blocks of life could spread to other planetary systems and possibly spark life elsewhere in the universe. The impending explosion of Betelgeuse is set to be one of the most significant cosmic events in recent memory. Its supernova will provide a wealth of scientific data, enhance our understanding of the universe, and undoubtedly captivate people around the world. Betelgeuse's death will mark the end of a giant star, but it will also represent the ongoing cycle of creation and destruction that governs the universe, reminding us that from death, new stars, planets, and even life itself can emerge. As we prepare for this historic event, the world will eagerly watch the night sky, anticipating the moment when one of the universe's most powerful forces detonates into view for both researchers and stargazers alike. As Betelgeuse approaches the last stage of its life, one of the more speculative but fascinating possibilities related to its impending explosion is its potential to shed light on some of the universe's greatest mysteries: dark matter and dark energy. These puzzling forces are believed to account for the majority of the universe's mass and energy, yet they remain poorly understood. Some speculate that supernovae, like the one expected from Betelgeuse, could hold the key to unlocking some of these mysteries. Supernovae release vast amounts of energy and radiation, and some researchers believe these powerful forces may interact with dark matter in ways we can observe and study. One intriguing hypothesis is that dark matter exists in the form of weakly interacting massive particles, WIMPs. If WIMPs exist, their interaction with the energy generated by Betelgeuse's supernova could provide clues to their nature. Such a discovery would be historic, offering the first direct evidence of dark matter, an elusive phenomenon that has puzzled scientists for years. Moreover, there is potential for Betelgeuse's blast to offer insights into the nature of dark energy. Dark energy is the mysterious force driving the accelerated expansion of the universe. Understanding its role in cosmic evolution is one of the most significant challenges in modern physics. Betelgeuse's explosion could provide indirect evidence of dark energy's influence on stellar death, as supernovae are thought to be affected by the universe's expansion. Any data that can shed light on this topic would be revolutionary. Betelgeuse's impending supernova is more than just a spectacular celestial event. It holds the potential to offer critical insights into some of the greatest unanswered questions about the universe, including the nature of dark matter and dark energy. Its explosion will be a powerful reminder of the ever-evolving nature of the cosmos, fueling the curiosity of scientists and stargazers alike. As scientists prepare for Betelgeuse's eventual supernova, the event offers an unparalleled opportunity to test and refine existing theories in astrophysics. One significant aspect is how the explosion will help astronomers improve models of stellar evolution. The transformation of massive stars into supernovae has long been a subject of study, but the precise mechanisms and variations in this process remain unclear. Betelgeuse, as a nearby red supergiant, will allow researchers to study the star's final moments in detail, providing data on the fusion processes in its core, the dynamics of its outer layers, and the shock wave produced during the collapse. This will enable scientists to fine-tune our understanding of how stars of this size and type evolve and explode. Moreover, the supernova could enhance our knowledge of neutrinos, which are fundamental particles that pass through matter with little to no interaction. The detection of these particles from a supernova provides a direct way to study stellar core processes that are otherwise invisible. For years, scientists have worked to capture these elusive particles, and the neutrino burst expected from Betelgeuse will offer a unique chance to track the behavior of these particles as they traverse through space and interact with detectors on Earth. This could yield important insights into the nature of neutrinos themselves and their role in the universe's fundamental forces. The explosion will also have significant implications for the study of gravitational waves. While black holes and neutron stars are often the primary sources of gravitational wave research, the collapse of Betelgeuse may produce waves detectable by observatories like LIGO, Laser Interferometer Gravitational Wave Observatory. These waves could provide further insight into the physics of massive stellar collapses and potentially even reveal new details about the structure of spacetime itself. Detecting gravitational waves from a supernova would mark a critical milestone in the new field of multi-messenger astronomy, where signals from different forms of radiation, such as light, neutrinos, and gravitational waves, are combined to provide a more complete understanding of celestial events. In addition to these scientific advancements, the Betelgeuse supernova could also inspire future space exploration missions. Understanding the remnants of a supernova, particularly the neutron stars and black holes that often result from such events, is crucial for planning deep space missions as humanity looks toward venturing beyond our solar system. Understanding how these extreme environments develop and behave could help in navigating and preparing for future interstellar travel. Beyond the scientific world, the explosion of Betelgeuse holds cultural significance. The event will ignite conversations about the life and death of stars, the vastness of the universe, and humanity's place within it. People around the world will marvel at the spectacle in the night sky, a tangible reminder of the impermanence of everything around us. This shared experience could foster a renewed sense of wonder and curiosity about the cosmos, motivating individuals to engage with astronomy, science, and the natural world in meaningful ways. Finally, as scientists continue to observe Betelgeuse's changes and prepare for the supernova, it serves as a reminder of the unpredictable and dynamic nature of the universe. While we have mapped out many cosmic phenomena, there is still much we do not understand. Understanding Betelgeuse's explosion will contribute to a growing body of knowledge, sparking further exploration and inspiring the next generation of astronomers, physicists, and space explorers. Betelgeuse's impending supernova is also a chance to explore how cosmic events influence the interstellar medium, the gas and dust that exists between stars. The shock wave from a supernova can dramatically affect this medium, triggering the formation of new stars or altering the structure of existing ones. By observing the interaction between Betelgeuse's explosion and the surrounding space, astronomers will gain insight into how these interstellar materials are shaped and enriched over time. This process plays a pivotal role in the life cycle of galaxies, contributing to star formation and the overall evolution of the universe. Furthermore, Betelgeuse's supernova will offer a rare opportunity to study the rapid changes in light and radiation as it undergoes its final moments. Researchers will closely monitor the burst of gamma rays, X-rays, and ultraviolet radiation emitted during the explosion. These emissions will reveal crucial information about the internal structure and temperature of the star, as well as the dynamics of the explosion itself. Understanding the precise mechanics of these explosive events will help refine models of star death and offer clues about the end stages of massive stars throughout the universe. In essence, Betelgeuse's death is not only a cosmic spectacle, but a vital piece of the puzzle in understanding the universe's continuous cycle of creation and destruction.